So we start with some introductory remark about introducing the trust into the critical systems, and we have analyzed the current state of the art and the work to assess what are the gaps in the current practice at the industrial level to fill and to respond to the IVV&Q requirement. So one of the major concerns is about the no widely adopted standards. So the current standards are ongoing, of course, but there is no established standard about the IVV&Q around the AI-based system. And also there is some fundamental properties that the systems, those kind of systems should guarantee is about, for example, trustworthiness, but primarily also the safety. And we focus on those different challenges to identify the different elements, building blocks that we will work on in the project. So this is like this, right? No, the other way. Okay. So we have, from the analysis of the state of the art, we have identified 4 challenges, main challenges. So there are subdivided also in sub-challenges, of course. One of them is to be able to identify and manage risk for the safety critical system that integrate AI. So one of the difficulties is about being able to accurately specify the operational context in which the system will be deployed, but also to deal with the new kind of hazard this AI integration will bring to the safety critical systems. The other challenges, one of the main challenges is about V&V strategy that we have to develop for those systems. Of course, as we said, there is no established standard to guide the process of the verification and validation of the system, but at least we have to identify how we can ensure some confidence in those systems when we build them and we produce them. Of course, we also have to deal with the assurance of the system during the operational time, because before the development assurance, you also have to guarantee that the system stay in his assurance, let's say, boundaries, frontier, and we have to develop the sufficient component to be able to assess that the different properties that we have put into the system during the development are still guaranteed during the operational data of the systems. Of course, you have also to deal with some other elements, challenge about, for example, the integration of human in this kind of system and so on. We primarily focus on the 3 first challenge during the batch 1, and we proceed on those challenges during this batch. So I will go just challenge by challenge, but of course there is some interconnection, interrelation between all these challenges. One of the work that we have developed so far is about working on the operational context definition formalization, the other analysis, let's say, topic, and how, after all, those different elements are linking. So one of the main artifacts that we have built is the work around the operational design domain, so the ODD. You have certainly have some, see some demo and some poster about the ODD in our village, bringing trust from ODD to data. And the main idea here is that the ODD is finally an artifact at system level that should be defined at system level, but that also should be used through the different phases of the product development. So, for example, we have used this ODD for the safety analysis to be able to generate all the different situations and assess them, the different situations in which the system can be deployed within. We also have to deal with how this finally data this ODD will help develop the data, the different data set for training the ML model and so on, the AI models, for validating them, and also for the verification or validation of the system, because what we have to guarantee is if I deploy the system regarding the mission that I have defined as his intended function, I should guarantee that at any time of his product life cycle, so it's not only about the development life cycle, but also after all, we are able to satisfy the different elements, conditions that we have put into the operational design domain. So the second challenge is about the providing justified confidence into the system. So we go through a general principle and we base it on the usage of assurance cases to develop a structured argumentation that will help provide this trust into the system. So this work has been developed in the village, the end-to-end village, because finally the V&V will be ended from the methodological level with the first system engineering activities, but after all, we have to deal with the V&V at the end of the process. So we have developed a methodology based on assurance case, as I said, that will help link all the different elements about the activities that we'll have to realize, to execute for the development of the system, the different artifacts that we have to produce, link them to the different properties of the system, and prove that we are able to demonstrate that we have satisfied those properties efficiently. So this is argumentation-based case, if I can say that. So we have developed a tool that enables to implement this strategy, and this tool is, of course, linked with all the overall engineering process that we'll be developing in Confiance.ai models. We also have to take into account the integration with the compliance with the different existing standards, because we have developed the argumentation with having in mind that there is some existing practice, of course, for the system, from the safety critical system, but also for the new requirements that are coming from this ongoing standardization activity that gives some rules and some indication about how we have to deal with the AI integration into the system. So we focus on not only on the AI or ML model development itself, but also on some other properties like the ALIX and so on. So the third challenge is about how we have to ensure that the system will still be enabled to provide his mission regarding the performance and the safety after the deployment. So we are working on some runtime system monitoring level. So in this approach, what we would like to define is the guidelines that will help monitor that the system will stay in his safety limit regardless of what will happen in the environment. Of course, we will rely then on the definition of the operational design domain, because it defines the boundaries of the perimeter of the environment that we are supposed to deploy safely our system. We will also rely on some reference architecture for an AI-based system, because we have some, let's say, standardized block about, for example, the perception, the sensing, the control, the decision, the planning, and so on. And for all those different elements, we will define the different monitoring rules that we have to put together to define some kind of overall global, of course, monitoring architecture, but also how we have to implement them and how we have to deal with the evaluation of the monitoring to give the correct decision and enable the system to stay in his safety frontier and boundaries. So that's under the talk. Of course, we are working on this different challenge, and as long as we are going through the different works, we realize that there is still new, let's say, issues that come up or new challenges that we have to address. Our goal is to go through those different challenges more deeply, to have more response and so on, but we also are working on how these different elements are connected together. As we said, for example, the ODD is important for the monitoring after the development of the system, but also the validation will come up at this stage, and we have to think about the dynamic, let's say, assurance, how we can prove dynamically during the operation of the system that we are still in the boundaries, and what we have developed has the guarantees through the argumentation during the development phases of the system. Thank you.